Hey guys, Mr. Riz to help you out with the day 5 of the 2.3. So now that we know how to do the product and quotient rule, we're going to go into another thing, which is called higher order derivatives. So higher order derivatives are basically derivatives of derivatives. We've kind of talked about this a little bit when it comes to story problems. So if we look at the derivative of the position function, that will give us the velocity, because the position or the derivative, the rate of change of the position, is a speed. Well, we can actually take the derivative of that. So the derivative of the velocity, or the rate of change of the speed, is the acceleration. So we can take the derivative multiple times. There is really no limit to how many times we can take the derivative. What we do though is if we take the derivative, we put that little apostrophe next to the function here to represent the first. We'll put 2 if we go to the second, put 3 if we go to the first. So you guys can see here with the first derivative, it's just like f prime of x, second is f double prime, triple prime. After that, we just kind of put a number there to represent like what derivative we would go to. All right, so typically what we will do in this class is we'll go to the second derivative, because after that, we won't be able to get too much valuable information. So the second derivative, let's find the first derivative of 4x to the 3/2 power. Oop, I don't want to use that. I want to use this one here so you guys can see. All right, 4x to the 3/2 power. Well, the first derivative, we just take the 4 times it by the 3/2, so that'd be 12/2 or just 6x to the, and we'll drop it down a power of 1/2. Now we could change this to 6 radical x, but since we're going to then take the second derivative, might as well leave it in that form and go through. All right, so 6 times 1/2 is 3. We'll drop that down another power to the negative 1/2. Now that we got it to our final one, we want to find the second derivative. That's when we should rewrite our answer. So this should be 3 over radical x. So there is the second derivative of f of x in this case. All right, let's keep this going. Couple more. Okay, this is where we start to have some fun with the product and quotient rule and second derivatives. So x times cosine x, we got to do the first derivative. Derivative of x is 1, we'll leave the cosine x alone. Then we'll put plus, we'll leave the x alone, take the derivative of cosine, which is negative sine of x. It's a terrible end. All right, so the first derivative is cosine of x minus x sine of x. Okay, well now if we want to take the second derivative, we need to take the derivative of the derivative. All right, so let's break this down. We have cosine x by itself. Cosine x goes to negative sine of x. And then what we're going to do is to do the product rule with the negative x times sine. So the derivative of negative x is just negative 1. We'll leave the sine of x alone. Then we're going to leave the negative x alone. We'll take the derivative of sine, which is cosine x. So we see if we can rewrite this, simplify this at all. If we have negative sine of x, that's negative 2 sine of x, and then minus x cosine of x. There we go. So there's the second derivative of that. Kind of crazy that the second derivative has the first function in it itself. Okay, keep this process going. Remember, you can pause the video at any time if you get confused or stuck. There we go. Let's draw this out. So, all right, we got low d high minus high d low. Okay, first derivative. Low is x minus 1, d high is 1. Minus high is x, d low is also 1. That's kind of nice. All over low, x minus 1 squared. So this ends up being, let's see, we would have an x minus 1 minus x. So really we would just get, after we distribute this here, just a negative 1 over x minus 1 squared. Okay, so there's the first derivative. Now if we want to take the second derivative, we'd have to do low d high minus high d low over low low, which ends up being kind of difficult when we have this. So what we might want to do here is just to figure out, okay, this is negative 1 over x minus 1 squared is x squared minus 2x plus 1. We might want to use the x minus 1 sometimes. We might x minus 1 squared, or we might want to use this x squared minus 2, 1. So let's go through and see what we can do. So if we want to find the second derivative, we will actually learn another way to do this problem in the 2.4 section, but let's go through this here. If we have low, let's just keep it as x minus 1 squared, and then d high, derivative of high is 0. Okay, so there's no reason to put this all out because we're going to times it by 0. It's going to go away. Then minus high is -1, and then d low. All right, we don't want to take the derivative of this. It'd be easier to take the derivative of that, which becomes a 2x minus 2. Yep. All over low, low. Now, low, low, I'm going to put x minus 1 to the 4th power. Because if we have the x minus 1 squared, and we're going to square that low, low, it comes to the 4th power. So let's clean this up. All right, this would come 0. That goes away, basically. -1 times 1, negative. That's a positive 1. So we get a 2x minus 2 over an x minus 1 to the 4th power. Which realistically is a good enough answer, but we can make this better. Because we could factor out a 2 from the top and make this a 2 times x minus 1 over x minus 1 to the 4th. And we could cancel this out if we drop this down to the 3rd power. So the final answer would be a positive 2 over x minus 1 cubed. Here is the second derivative of that. Okay. Let's check out this next problem here. And yeah, that's as far as we're going to go. All right. If the third derivative is 3x to the cubed minus 2x squared plus 1, if we want to find the fifth derivative, well, if we just take the derivative of the third, that gives us the fourth, which would be 3x squared minus 4x, and the 1 goes away. To get the fifth, all we need to do is take the derivative of that. Unfortunately, there's no quick way to go straight from the third to the fifth or like the 7th to the 20th. You just got to go through each one at a time. All right, 3x squared becomes 6x, minus 4x becomes minus 4. So that's the equation. Okay, so hopefully you guys get the hang of this. Today, what you guys will do is the worksheet that's attached. Let's take a look at it right now. Remember, there is the answer key online that you guys can look at to help you out. So all of these here, if you see, oh, d squared y dx squared, that just means second derivative, or d cubed y over d, that means third derivative. That's fourth derivative. So just look at these. Some of these you guys go to the second or the third. A simple polynomial makes it pretty easy. Alrighty. Yeah. And then think about this one here. Yeah, these are kind of good process, but you guys have those 9 problems. Make sure you guys show your work to get credit for this, and take a look at the answer key to make sure you are doing this correctly. You guys have a great day. I will see you next time.